All right, so for this problem, we are being asked the arc length of the graph of ln cosine x. So we're essentially using our skills towards something that we discussed about in the previous chapter. We need the arc length formula. That arc length formula comes with the derivative of the curve. So first of all, why don't we have the derivative of ln cosine x to start with? So y prime is ln cosine x prime. So we can use the chain rule for differentiation here. So the outer function is ln, inner function is cosine x. So the derivative of the outer function is cosine 1 over, so it's like calling, let me just do it in one shot, calling this to be u. So the derivative written here is like u prime over u. Here we go. Okay, so then u prime is negative sine x, and then this is cosine x. Okay, so it's negative tan x. All right. So I need 1 plus y prime squared in the arc length formula. Okay. In fact, let me just write down the arc length formula in just one shot here so you can see what I'm talking about. So the arc length formula is the integral from 0 to pi over 3 in square root 1 plus y prime squared dx. Okay? So that's what we're trying to get to. So I need to simplify. 1 plus y prime squared x. Okay, so let me just do that right here. Okay, so 1 plus y prime squared x equals 1 plus negative tan x squared. That's 1 plus tan x squared. All right, so there's a Pythagorean formula for that. So 1 plus tan squared equals secant squared x. Let me see if I have that listed here. Okay, so there's a different version of this formula. 1 plus tan squared x equals secant squared x. Okay, so that's what I'm trying to use. In fact, this formula is derived out of sine squared plus cosine squared equals 1. So that's exactly what I'm using here. So this is going to be equal to secant squared x. Okay. So that allows me to write or simplify this formula to secant squared x dx. Okay. Well, this is the square root of a quantity squared term. Okay. So why don't we simplify that in the next slide? Integral from 0 to pi over 2. Secant x dx. Okay, so now we got to rely on one of the basic integration formulas here. Okay, that is in fact the integral of secant, let's see, secant u, I'm sorry, not 16, but 12. Okay, so that should be 12, right? So secant u du is integrated as ln absolute value of secant u plus tangent u, and in our case u equals x. All I'm going to do here is just writing this as ln secant x ln secant x plus tan x in the absolute value, and using the fundamental theorem of calculus, because this is a definite integration. Okay, so let's plug in pi over 3 ln of secant pi over 3 plus tan pi over 3 minus ln secant 0 plus tan 0. Well, at this moment, please pause the video and have your TI-84 ready, and then do this calculation on your own. And don't forget to put your calculator in the radian mode, okay? But it turns out, you can always pause the video. It turns out that this is equal to ln 2 plus radical 3 minus ln 1. But ln 1 is equal to 0, so ln 2 plus radical 3 is the final output here. And I do not, by the way, recommend you to use decimal places till you get the final result, okay? And now I have the final result written in the exact form. Go ahead and punch in ln of 2 plus radical 3 to get 1.0 So that's equal to 1.317 approximately. So the arc length of the curve ln cosine x from 0 to power 3 is found to be approximately found to be 1.317. Okay. All right, that ends the video. Thanks for watching. I'll see you in another video. Bye.